Good morning, students. Today's experiment, third experiment, is a single tuned voltage amplifier. The aim of the experiment is to study and plot the frequency response of a single tuned voltage amplifier. Second point is to find the resonant frequency, and third point is to calculate the gain and bandwidth. The software required is a Multisim Analog Devices Edition 13.0. And we have a components. If you see the circuit diagram, this is a circuit diagram. You have a input function generator, you have a resistance of 150 ohms and a capacitor of 10 microfarad, and a resistance R1 of 47 kilo ohms and R2 of 10 kilo ohms. And here at the collector section we have a tuned circuit. That is nothing but you have a inductor as well as capacitor. The inductor is 1 millihenry, and the capacitor, it's a variable capacitor. You can go for 0.022 microfarad or 0.033 microfarad. So two values, it is a variable. You can take either the two values here, and here you have a output capacitor of 10 microfarad, and at the emitter section you have a resistance of 1 kilo ohms and a capacitor of 22 microfarad, and you have a load resistance of 10 kilo ohms. So this is the frequency response of a single tuned amplifier. So this is a frequency response of a single tuned amplifier. The tuned amplifiers are amplifiers involving a resonance circuit. This is a resonance circuit, and are inducted for the selective amplification with a narrow band of frequencies. We have a narrow range of frequencies where these frequencies are used in radio and TV amplifiers employed to tuned amplifier to select one broadcast channel from among the many concurrent induced in an antenna or transmitted through a cable. The selected accepts of tuned amplifier are reviewed in the parallel resonance circuit. So this is a parallel resonance circuit which is used. By placing this parallel resonance circuit, we find we have a narrow range of frequency. That is nothing but you have taken as f naught. So this narrow frequency range f naught is used for various applications, right? So let us connect this circuit and check the output waveform, the frequency response, using a Bode plotter. And if you go for, you have a tabular here, observation table. Here you are going for two values of a capacitor, that is a variable capacitor. C is equal to 0.022 microfarad, and with a V in voltage of 50 millivolts and 1 kilo. The frequency range you can vary from 100 hertz, and you can note down the V output voltages, and you find the gain, that is nothing but V out by V input voltage, and you can go for gain in dB now to draw the semi-log graph. Similarly, you can change the capacitor value. C is equal to 0.033 microfarad for the V in voltage 50 millivolts, and vary the frequency 100 hertz, 20 hertz and 40 hertz and 800 hertz, and check the outputs voltages for corresponding frequency ranges, and find the gain A is equal to V out by V in, and write the corresponding gain in dB for all the frequencies. So by this observation table you can draw the Bode plotter here. So now let us design the circuit. So as we know, this is a circuit which we have, and let us design this in Multisim software. Now first place the resistor. Go to place, component, resistor, all groups you go for basic. In basic you have a resistor, and resistor is of input resistance is how much? Of 150 ohms. Place the resistor here. And next you have a capacitor in series. Go to place, component, the capacitor of 10 microfarad. Next you have a resistors R1, the biasing resistance. Go to place component resistors. Resistor is of 47 kilo ohms. And go for another resistor. Place component resistor of 10 kilo ohms. Next you have a transistor. Go to place component. In basics you go for transistor. Transistor is BC107 BP. BC107 BP. Okay, place the transistor here. And next go for inductor and capacitor at the collector section, which is parallel. Go to inductor. Basics, you have an inductor. Inductor is of 1 millihenry, 1 M. And parallel to it we have a capacitor, variable capacitor. I am going for 0.033 microfarad. Go to place component capacitor 0.033 microfarad, right? And you have a input capacitor, output capacitor of 10 microfarad. And we have a emitter. At the emitter of the transistor we have a resistor as well as the capacitor. Now go place the resistor of how much is 1 kilo ohms. And you have a capacitor of 22 microfarad, capacitor of 22 microfarad. And you have a load resistance of 10 kilo ohms, resistor of 10 kilo ohms. Now place the components, all the components in the proper way in order to connect our circuit. So rotate this R1 in 90 degrees clockwise direction, and rotate this R3. Okay, and rotate this L1. So that it should be parallel to the capacitor. Rotate the capacitor also, right? Okay, connect this. And rotate this also, R4. Rotate the capacitor, and this is the load resistance. Rotate it and keep it at the output section, and connect the circuits. Make sure we should have a node here always, and we should give the VCC voltage here, and this you have to connect a common ground here. Connect the load resistance to the common ground. So give the VCC voltage, go to place, component. In basics you go for sources, power sources, go for ground as well as VCC, and similarly go for ground also. Click on OK, place the ground. So now check all the values here. Input resistance is R1 150 ohms, the capacitor is 10 microfarads, and R2 is 47 kilo ohms, R3 is 10 kilo ohms, and the L1 is 1 millihenry, and the capacitor value C2 can be either 0.022 microfarad or 0.033 microfarad, and here C3 will be 10 microfarad, and we have a emitter resistance of 1 kilo ohms and 22 microfarad, and we have a load resistance where output is taken. Now check this value, change the value VCC as 12 volts. Okay, so now give the input from the function generator and check the output in the Bode plotter as well as oscilloscope. Go to the input function generator, place the function generator here, where input is given to the resistance R1 and this is given to the common end, and we have an oscilloscope, and we have a Bode plotter also. So channel A I am taking as output, so directly A is given to the capacitor and the negative is given to the ground. Similarly B I am given to the input, and B negative I am giving it to the ground. Similarly the Bode plotter also, input means I need to give to the input point of the function generator, and negative it should be connected to the ground, and output I need to give to the output across the load resistance, and the negative I need to connect to the ground. So these are the connections which we have done with. And now go for the input frequency. Input you can start double click on it, go for input frequency of 50. Amplitude, yeah, we need to take for 50 millivolts peak to peak, and the frequency you can go for 100 kilohertz or 1 kilohertz frequency. So set this, and now go for a run, double click on the signals, you will get the output. So input we have given how much, input we have taken for channel B, right? So channel B, how much is the channel B? 500 milli, right? Though change the time based scale also. So, and if you need to, you can change the output waveform, whether you know whether need to know the difference. So go for channel A, double click on it, you can change the color of the signal in order to differentiate the input signal with the output. Apply, okay. So okay, stop and run. So this is the output signal, this is the input signal which you have given. So I have, how much I have given is 50 millivolts, right? The output is 5 millivolts. So go for the AC points here, right? So this is the output waveform which you have got, right? So now let us check the Bode plotter. So here in the Bode frequency response we need to get the narrow frequency, right? So that is what the use of the single tune. By placing the tuned amplifier we need to get a narrow frequency frequency range. So go for a Bode plotter, double click on the Bode plotter, you will get it. So here change the initial value as 0, and final, change the final as so this is a frequency response. So you can see we have got a narrow range of frequency. So this curve, the So you have a curve here. So if you you have a curve at the input section, if you remove the capacitor resistance, we can get the normal curve here. So let us change the capacitor, remove the cap. So so see here, this is a frequency response. We have a narrow range of frequency range which we have got. So the maximum frequency, the gain is 48.485. It is a gain for the frequency range of 479.522 hertz. Similarly, if you change the value, if you change the value of the capacitor, that is how much is 0.022. Change the value of capacitor 0.022 microfarad. You can check the output waveform. So let us check the F naught is 49. Is 49 for 667.12 hertz frequency. 49 is a F naught. The narrow frequency range is F naught, that is taken as 579.505 hertz with the gain of 449.48 dB. So this is the frequency response of single tuned amplifier, which shows you the narrow frequency range. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.